Welcome to Homework Lib.
Hi, so we're here for the following reaction of 6 carbon as a solid plus 3 of hydrogen gas, producing C6H6 as a liquid. We want to calculate the delta G for the reaction in kilojoules. Given the following information, we are told that the combustion energy corresponding to 2 moles of C6H6 liquid plus 15 of oxygen gas, producing 12 of CO2 plus 6 of water liquid, CO2 gas, of course, is going to have a value for delta G equal to minus 6,399 kilojoules. The next reaction that we're going to consider is going to be carbon as a solid plus oxygen as a gas, which produces CO2 as a gas. This is going to be the delta G of formation of CO2, which is going to have a delta G of minus 394 kilojoules. Following this, we're going to have the formation of water with hydrogen gas plus 1/2 of oxygen gas, producing H2O as a liquid, with a value for delta G for this reaction equal to minus 237 kilojoules. So over here, what we're going to do is apply His law in order to get our final answer. So first of all, we need to identify the number of reagents and of products that we're going to get. In this case, we need to multiply. In the sides of the products, we're going to have the C6H6. So we need to invert the first reaction and multiply it by a 1/2 factor. Next up, we're going to have 6 carbon atoms over here, so we are going to require 6 in this case to cancel things out. Notice that the CO2 over here is going to cancel with the CO2 of the inverted reaction for the first process. And finally, what we're going to get is an extra requirement of 3 hydrogen atoms. So over here, sorry, for 3 hydrogen molecules. So over here, we need to multiply the last reaction by 3. After doing so, what we're going to get is that the reactions that we're actually considering are going to be the following. First of all, let's skip it. 6 of CO2 plus 3 of water, producing C6H6 plus 15 halves of O2, with a delta G. In this case, it is going to change the value. We're going to have 1/2 of the value that we get over here. So it turns out as positive 30,199.5 kilojoules. The next reaction, we're going to leave things as they are. We're simply multiplying by 6. I'm going to express the 6 over here as 12 halves of oxygen, just to simplify our calculations later and to cancel things out in a faster way, plus 6 of CO2 gas. In this case, the delta G associated to this is going to be 394 times 6, and still we're going to keep the negative value. So minus 2,364 kilojoules. And finally, for the last reaction, we're going to have 3 of hydrogen gas plus 3 halves of oxygen that are going to produce 3 water molecules as a liquid, for which the delta G is going to be 237 times 3, and we're going to give the negative value since we didn't switch up the reaction. So now we can add up all of the reagents and the products and get the overall reaction. You're going to see that we're going to find the actually desired reaction over here. We're going to cancel 15 halves with 12 halves and 3 halves. Next up, 6 CO2 cancels out with 6 CO2, 3 water molecules with the 3 water molecules, and we end up having the desired reaction. 6 carbon solid plus 3 hydrogen gas produces C6H6 as a liquid. And the value for delta G is going to be simply the sum of the different delta G's that we had previously, which is going to be equal to 124.5 kilojoules. And with that, it would be all. Thank you very much and have a good one.